What if an AI could see the world not just as a flat picture, but with layers of understanding, just like we do? Well, today we're diving into a really cool breakthrough that's making that a reality.
Think about it. When you look at a picture of a forest, you see the whole scene, right? But you can also zoom in with your mind and focus on one tree, or even the tiny texture of a single leaf. So what about an AI? How does it see that exact same image?
Well, for most AIs, the answer is kind of flatly. And that creates a really fundamental problem in how they perceive, everything around them. You see, our perception is all about layers. It's hierarchical. We see the big picture, then the objects inside it, and then the little tiny details. But a standard AI, it just sees a flat sea of pixels. Sure, it can be trained to spot objects, but it doesn't really get the underlying structure. To the AI, it's all just one giant flat canvas of data.
So, how do we fix this, right? How do you teach an AI to think in layers? Well, the solution is actually surprisingly elegant, and it comes from a place you might not expect: the world of sound. We're going to teach it to think in frequencies.
The core idea is called a tri-frequency prior. Now I know, that sounds super technical, but stick with me. The best way to think about it is like an audio equalizer for an AI's brain, what developers call its latent space. Just like your car's stereo's EQ separates a song into bass, mids, and treble, this method forces the AI to process everything it sees in 3 distinct frequency bands. And this is where it just clicks. Check this out. The low frequency band, that's like the bass in a song. It represents the global structure, the whole layout of the scene. The mid-frequency band is the melody. It defines the actual shapes of objects and how they're all arranged. And then you have the high-frequency band, which is the treble. All those crisp, fine details, the textures and the sharp edges. It maps out perfectly.
Okay, but why go to all this trouble? What's the point of separating everything out like this? Well, it gives us an incredible amount of control. It's like having volume knobs for each of these layers. We can crank up the bass to force the AI to learn a really solid structure, and maybe turn down the treble to let it get a little more creative and abstract with the details.
All right, this all sounds pretty cool in theory, right? But what does it actually look like when the AI does this? Let's take an image and really see what the AI sees when we force it to look at only one frequency layer at a time. Here we go. This is the image put back together using only the low frequency, that base layer. And as you can see, it's just the gist. You get the overall shape, the composition, the layout of the scene, but there's absolutely no detail. It's just the big, blurry picture. Now, let's switch to the mid-frequency, the melody layer. Whoa. See? The overall context is gone, but the objects themselves just pop into focus. We see their shapes, their outlines, we have the what, but we don't really have the where or the what it's made of. And now for the grand finale, the high-frequency treble layer. And this is what's so brilliant. With this layer, we see only the fine details, the textures, the sharp edges, all those intricate patterns. There's no coherent shape or structure at all, just pure detail. It's amazing. The AI has successfully taken the image apart into its core building blocks. So this is obviously a game changer for images. But here's the bigger question. What if this whole idea, this language of frequencies, applies to, well, everything? What if it's a universal principle for how the world is structured? I mean, the researchers behind this put it perfectly in their paper. Natural signals exhibit multi-scale structure regardless of their physical origin. That basically means that whether we're talking about an image, a sound, or even a video, the world is just naturally organized into these layers of information, from big picture to tiny detail. Okay, get ready, because this is where things get really, really cool. Take a look at how this frequency language just fits across totally different senses. That low frequency that gives you the global layout in a picture, that's the exact same thing as the rhythm and tempo in a piece of music. The mid-frequency of object shapes, that maps directly to melody and harmonics. And the high-frequency textures and edges, in audio, that's the timbre, the sharp, crisp sounds. It's a shared universal language. So, if you have a shared language, what can you build with it? You can build a shared brain. And that's really the ultimate goal here. A single AI that can understand the world through multiple senses all at once. The way they're building this is called a shared latent space. It sounds complicated, but the idea is actually pretty straightforward. You have different inputs, an image, a sound, a bit of text, and each one gets processed on its own.
But they all feed into this one central shared brain that's structured by this frequency principle. And from there, you can translate that unified understanding back out into any format you want. So what does that really mean? Let's make it super simple. It means we can build an AI that doesn't just know what a lion looks like over here and what a lion sounds like over there as two separate facts. It means building an AI that understands the deep, fundamental connection between the image of a lion and the sound of its roar, because it represents both of them using the same underlying layered language. Look, this is so much more than just a clever technical trick. Giving an AI this kind of layered perception, it fundamentally changes the game. So, what are the big takeaways? Why does this matter so much? It really boils down to three huge benefits. First up, interpretability. For the first time, we can literally peek inside and see how an AI is thinking by looking at each layer. Second, control. We can go in and edit just one layer, like changing the artistic style of an image, without messing with the people in it. And third, efficiency. Because the structure mimics the real world, the AI just learns faster and becomes way more robust.
And that really brings us to the final big idea here. We've spent decades just trying to get AI to recognize what's in a picture, but now we're right on the cusp of giving it the ability to perceive the world with genuine depth and structure. So the real question we're left with isn't just about building a smarter AI. It's about what truly becomes possible when an AI can finally perceive, understand, and create in layers, just like we do.